Good morning, dear student. In today's lecture, we will discuss the anti-cancer activity of the gold complexes. In previous lecture, we already discussed the anti-arthritic properties of the gold compound. The discovery of anti-tumor activity or anti-cancer activity of this cisplatin prompted the search for other metal containing anti-tumor drugs. So we are very much familiar with this cisplatin, that is the platinum complex containing 2Cl and 2 amino ligand used as a anti-cancer drug, and therefore the discovery of this anti-tumor activity of cisplatin prompted means to enhance the search for other metal containing anti-tumor activity or drugs. There were early indication that ornithine has limited antitumor activity. So we already discussed this ornithine. It is used in rheumatoid arthritis. So it has a limited antitumor activity in vitro and vivo things. So in vitro means non-living things, and in vivo means living thing. It was inactive against solid tumors. It is inactive against solid tumors. Several other gold phosphine complexes with thiosugars ligands also investigated with similar kind of results. So they are not useful as a anti-tumor. They does not have anti-tumor activity or does not have a property such as anti-cancer activity. More promising indications were achieved with the series of digold phosphine complex. More promising indications are achieved with the series of digold phosphine complex. Digold phosphine complex. So this digold phosphine complex in which the gold is in +1 oxidation state. This EU, it is in +1 oxidation state. EU, it is in +1 oxidation state. Digold phosphine complex having a anti-cancer or anti-tumor activity. For example, the example of this category, that is digold phosphine complex, is DPPE having AuCl2. So what is this DPPE? So we are very much familiar with this ligand. It is diphenyl phosphoethane gold chloride. It is diphenyl phosphoethane gold chloride. Diphenyl phosphoethane gold chloride. Diphenyl phosphoethane gold chloride. If you see the structure, then it is P. This is P, which is attached to this phenyl. It is also attached to this phenyl. pH. You can write this as your pH. This is your pH. And this phosphorus again attached to this AU. So you can write this as. Okay. So the best example is what? That is diphenyl phosphoethane gold chloride. That is phosphorus, which is attached to AU, and the AU attached to Cl, and this phosphine, it is attached to phenyl. pH again, it is pH. So these complex, gold first complex, having an activity, that is it has an anti-cancer activity. This DPPE, that is diphenyl phosphoethane, itself exhibit antitumor activity. So you should remember this DPPE itself exhibit anti-tumor activity. Itself exhibit anti-tumor activity. Again, the digold complex, which is shown, undergo rearrangement to give a tetrahedral complex such as, so this complex undergo rearrangement to give a tetrahedral complex such as, so what you get here, AU DPPE twice having a positive charge, and it having a tetrahedral structure, it having a tetrahedral structure, tetrahedral geometry, we can say that it has a tetrahedral geometry. So this is another complex of gold. It is also used as a anti-cancer drug, or it has an anti-cancer activity. So let us discuss its structure. That is, this diphenyl phosphoethane gold chloride complex undergo rearrangement to give a complex in which EU having positive charge, and then it is attached to this phosphorus, 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 and phosphorus. So these are above the plane and these are below the plane, so we can write this as, and they are attached. Again, this phosphorus, we can write this as, this phosphorus, so we can write this as, it is attached to carbon. Again this, and this phosphorus then again attached to this phenyl ligand. Again here pH, pH, pH. Okay, so this is your EU DPPE twice having a positive charge. So it is a gold first complex. It is also having an anti-cancer activity. So the tetrahedral complex is more stable. No doubt it is look like a square planar complex, but actual geometry is tetrahedral. A tetrahedral complex is much more stable as the chillate effect stabilize the compound, because if you see, there is a 5-membered ring. This is one and this is second. Two 5-membered rings are forms. A chillate effect is there, so the chillate effect stabilize the compound, and the first point ligand is more inert to the substitution by the type of the thiolate ligands that could be encountered in biological environment. So due to the chillate effect, the complex is much more stable, and the ligands, that is phosphine ligands, are more inert to substitution reaction. They does not undergo substitution reaction. So this is regarding to the gold first complexes. uh, Other example of these gold first complexes are triphenyl phosphine gold first, triphenyl phosphine gold first, nucleotide complex, nucleotide complex, nucleotide complex containing ligand, containing ligand such as 5-fluorouracil, 5-fluorouracil, and 6 mercaptopurine, mercaptopurine. So you should just remember the names, that is triphenyl phosphine gold first nucleotide complex containing ligands such as 5-fluorouracil, uracils, and 6 mercaptopurines. So these are the gold first complexes which are having anti-cancer activity. Let us discuss some gold third complexes. The gold third complexes uh, have not been throughoutly investigated as gold first complexes, because if you consider these gold third complexes, so we are very much familiar with these gold third complexes. It has a D8 configuration, and which is isoelectronic with pt second. This EU third, it is isoelectronic with D8 configuration, that is isoelectronic with D8 configuration of pt second, and therefore it generally form a square planar complex. It generally form a square planar complex. So it is isoelectronic with platinum second having D8 configuration, and therefore it generally forms a square planar complex, and it has the same activity such as cisplatin. So the no difference between this cisplatin and this gold, because of their reactivity. So it is less reactive, and it is isoelectronic with pt second, and it will form square planar complexes. Okay, one approach has been synthesized the complex with single mononegative bidentate ligand. One approach has been synthesized the complexes with a single mononegative bidentate ligand such as DAMP, DAMP. So DAMP. So what is this DAMP? It is 2. So we can consider it is 2 dimethyl amino, 2 dimethyl amino methyl phenyl. What is this DAMP? It is 2 dimethyl amino methyl phenyl and 2 monodentate anionic ligand. So with the help of this DAMP and another, that is 2 monodentate. So this is your bidentate ligand. This is your bidentate and monodentate ligand. Monodentate ligand such as chlorine and OAC, acetoxy or acetate group is there. Okay, Cl and acetate ligand is there. That is one of the approach has to synthesize the complex with single mononegatively bidentate ligand such as DAM and 2 monodentate anionic ligand having anti-cancer or anti-tumor activity. So what is this DAM? If you consider this DAM, it is a bidentate ligand. So this ligand forms a part of the ligand. It has the part of 5-membered chelate ring in which the nitrogen of the amine group and the carbon of the aryl rings forms the bond with metal atom. So let us discuss the structure, that is AU Cl2, and this is your DAMP, DAMP, AuCl2 DAMP, in which gold is in +3 oxidation state. So if we see the structure of this complex, Cl, then it is attached to this nitrogen, then it is attached having one carbon, it is attached to this nitrogen, and this nitrogen it is attached to this gold. So what is this DAMP, DAMP? It is a bidentate ligand. The ligand forms a part of 5-membered chelate ring. 5-membered chelate ring. So this is your 5-membered chelate ring. So it contains 2 carbon, 3 carbons, 1 nitrogen and 1 gold. So it is the ligand forms a part of 5-membered chelate ring in which the nitrogen of the amine group, the nitrogen of amine group. So this is your CH3 group, the nitrogen of amine group, and the carbon of the aryl ring. So this carbon of the aryl ring forms the bond with metal, and the monodentate ligands. So these are the monodentate ligands, such as Cl and Cl, or acetate group. So they are readily hydrolyzed and available for substitutions. So if you consider another example of this EU third, that is AU, then it is OAC twice, and it is DAMP, 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 AAC, damp. So again, if you consider its structure, then it is similar, only the replacement of the chlorine ligand, that is AU, it having nitrogen, this forms, and this group, it is replaced by OAC, acetoxy groups, that is O2CMe, this O2CMe. Again, in this case, the complex in which gold is plus 3 oxidation states. So these are the few complexes in which gold is plus 3 oxidation state and it having an anti-tumor activity. So this is all about the anti-cancer or anti-tumor activity of the gold complexes. In next lecture, we will discuss the remaining points regarding to this chapter. Thank you.